Hi, in this video we're going to continue with arithmetically increasing annuities, and in fact we're going to look at perpetuities in this case. So the general increasing perpetuity is going to look like this. We're going to have a first payment I'm going to call P, and then I'm thinking of the common difference as being a Q. So the next payment would be P plus Q, the third payment would be P plus 2Q, and so forth. And I want to take a valuation date one period before the first payment. So this would be representing the present value at that date. It would be the present value of a general increasing perpetuity immediate. So I want to spend the next few slides going through what the formula is for this. It's a very useful formula. I strongly recommend that you commit this formula to memory. So in order to derive the formula, I want to rewrite the payments in a certain form here. I want to think of the second payment of P plus Q as a payment of P, and then the Q payment on top of that, and then the P plus 2Q payment as a payment of P, and then 2Q on top of that. So I'll just rewrite the payments this way. So then the present value is easy for me to symbolically represent that present value. The present value of the level payments of P at the valuation date would be, I'll color code this, would be a P times an A angle infinity, and then the payments of Q, I could value at the valuation date using a Q times an IA angle infinity. That IA angle infinity gives me the value one period before the first payment of Q, so then I need to discount that back a period, and I would do that by multiplying by a V. That's why there's that factor of V on the end there. So let's focus on some of these expressions. The A angle infinity is, the closed-root formula for that is 1 minus V, actually to the infinity minus 1, but of course V to the infinity is 0. V is a number between 0 and 1, and if you raise that to higher and higher powers, it's approaching 0. So V to the infinity is 0. And so the A angle infinity is just a 1 over I, so the first term in the present value expression becomes just a P divided by I. Now what about the second term in the expression in blue? Let's look at the cap IA angle infinity times V part. Well, first let's look at the cap IA angle infinity closed root formula. That would be an A double dot angle infinity minus infinity V to the infinity, using an infinity for n, all divided by I. And then of course I'm multiplying by that V on the end because I have that extra factor of V. The A double dot angle infinity, the first term in the numerator there, A double dot angle infinity would be a 1 over D. So I got a 1 over D, and then I'm doing this in two steps, minus the infinity V to the infinity power. Now that's an indeterminate form actually, infinity times V to the infinity, because the V to the infinity is 0. But the fact of the matter is that the product there, infinity times a 0, the V to the infinity is 0, is being dominated by that 0 factor, because V to the infinity is going to 0 much faster than the infinity is going to infinity. So just I hand wave through a little subtlety there. Punchline here is that the infinity V to the infinity is actually approaching 0, so that's not there anymore. I just get a 1 over D divided by I times a V. Then the D I think of as, well, D is an I times V, so I can substitute an I times V in for that D. And when you distribute that V, the last factor of V across, you end up with just 1 over I, and then that divided by I, so it's a 1 over I squared. So what Q is being multiplied by there is just a 1 over I squared. I'll come back to that in just a second. So the valuation date, with the valuation date one period before the first payment of one of these general increasing perpetuities, the present value is the first payment divided by I plus whatever the common difference is divided by I squared. So that's the present value of a general increasing perpetuity immediate. It's a very useful formula. I strongly recommend that you commit that formula memory. Remember that formula, and also remember where the valuation date is when you're using that formula. Okay, I'll see you in the next video.